In some cases, you have to use function expressions, really. Inline anonymous function expressions, especially when we're using those array methods, that's what it's kind of expecting. So, yeah.
So then your expectation, let's say for the assignment, if I wrote something as a function, but I could have done it as an arrow and it would have been better?
Well, arrow is a function. And so if you did it as a function declaration, or a function expression, or a function, arrow function expression,
doesn't matter to you.
Doesn't matter to me. The only thing is the difference between function expression and function declaration. Function declaration, right? Remember, that's this. This is a function declaration. This is a function expression.
Right.
This is an anonymous inline function expression. Here, you kind of have to use an inline anonymous function expression. You can't really use a function declaration here. It doesn't work. I guess
would it?
It does.
You'd have to just write the whole function though within the line, right?
Yeah, no, I guess it would work. Yeah, doesn't really matter.
No.
You are writing the whole function in here. But it doesn't really matter, that's just weird though. It's very weird. Inline named functions is weird. Array of numbers. We're getting an array of numbers. We're going to add them up, which means we need some sort of accumulator. Let total equals 0. Because we're going to be building up this accumulator, and it's going to return a value at the end. How do we iterate over an array? For loop. We've got 3 different for loops we can use. We've got the for, we've got the for of, and we've got the for each. For each would be pretty complicated here. Like, not complicated, it'd be extra lines and a lot of extra syntax. For loop, where we're counting from 0 to array.length, that's not bad. But let's try nested for of loops. Let's see what that looks like. So we want to iterate, we need to get to these arrays, and then we need to get inside of them. We need to get the element inside the element. So we're going to start on the outside. For let inner array of array of numbers. So now we're inside of the loop, and inner array is this, then that, then that, then that. What's inside these inner arrays? Well, what are those things called? Elements, but what kind of value? What kind of data type? Numbers. Let's call it a number. For let number of inner array. So this for of loop gets us inside and allows us to go over each of these things. This inner array lets us go over each element inside of those things. And we end up with number. Total equals plus equals number. Return total. Okay. I feel like with the for of loop, maybe it's a little easier because we don't have to do all the x plus plus, x less than array of numbers dot length, x equals 0, go inside, like, right? A lot of the for of loop gives us a lot of simplicity and makes it easier for us to kind of wrap our head around going into an array and then getting that value out and checking and getting the value going inside of that inner array. Am I wrong? Does this Do you feel like this makes more sense? I can rewrite this. And we can take a look at what it might look like as a for loop. As a real for loop. And we'll compare. Tell me which one you like better.
What does plus equals do in that number in the for again? It adds everything inside.
Yeah, it's like a sum.
So what's the long version of plus equals?
It's like total equals number plus.
Okay,
Number plus
Which
number
one?
plus number.
this one or this one? Do you like better?
The bottom one.
Really?
The first one.
Really?
In this case.
The first one?
In this
Yeah.
case, yeah. For this case.
Second one? First one? Interesting. Okay. You know what? This is not like a factual thing. Like, fact, this is better.
No, it's
Not
true.
a
Okay.
fact, right? If you like that one better, that's fine. If this resonates better with you,
Mhm.
no problem. If this resonates better with you, great, right? This is the reason why the for of loop was even invented. It's convenience and developer happiness, right? For a lot of people, this does make more sense, and so that's why it was created in the first place. But it's really just this, and so whichever one you feel like resonates better with you and provides better understanding, feel free to use it.
I think that bottom one just makes more sense for me because we've been using it.
Yeah.
I
I
feel.
think if I got used to the other one,
I feel the last one is powerful than the first one. More powerful for more flexible.
It is more flexible.
But for this
Yeah.
case, I prefer the first one because I figured out what solution I need to implement. So.
Okay, so I've gone ahead and commented out the bottom one, put a little comment on there, just so you know. Okay, but you have both for comparison. I've also gone and done the same thing for all the other ones. I commented out the arrow functions and identified them specifically. So you have two versions. Okay. And let's see if this works. Console. Okay. And we're going to do it again. Because that's what question 6 asks. Except this time, we don't know if the element is going to be an array. Here, on the previous one, we're under the assumption that each of the inner elements is an array. But if it's not an array, we're kind of going to run into a problem. Okay, because we can't iterate over, we can't loop over something that's not an array. In fact, I suspect we will run into an error. Yeah. Inner array is not iterable. It's not an array, so I can't traverse it. I can't iterate over it. Okay? So, what I ask you to do now is go look up is array. Is array. So, is array method. Definition and usage. The is array method determines whether an object is an array. The function returns true if the object is an array or false if it is not. The syntax. Array dot is array object. Little bit different of the syntax than we're used to for array methods. So it looks like this. If inner array if array dot is array, inner array, then loop over it. So we haven't seen anything like this yet. Capital A array dot inner array. We haven't seen that yet. This is new for us. Okay? And that's okay. That's okay. But this is a nice tool to have. Again, I can't cover everything with you. Right? So there's a certain expectation that you're able to research stuff on your own and figure out how to use it. Generally, on a day-to-day basis, people won't even tell you, you need this tool to go do this. Go look it up before you solve this problem. It's just, here's the problem. And then you're doing whatever you need to. So I'm helping to guide you and saying, go look at this, go check this out, do this with this, do this with that. Okay? On the assignment, I'm not going to, right? It's just going to be, just do this. And use whatever tools you need to. People are going to have very, very, very different approaches. And if I was to do this, down in this loop one, it would just be the same thing. I just wouldn't run the inner loop unless this passed. Okay. And then if we run that, we should get 45, which is what we should get. Same amount? Returns 45. Yeah. All right, and now the bonus one we pretty much did in class yesterday. We sorted an array of numbers and we reverse sorted it. So I'll do it for you again. Bonus. So we're going with, starting with Christopher. Const string length sort equals names, arrow function. This is an array of names. And we are going to return, because sort returns the array. It actually it does both. It modifies the original array and returns the array. So the really interesting thing here is even if I declared the array out here, we would see that the array would be sorted. Well, I'll show you after. Return names.sort. And we found that if I just ran this, console log. If I just run this, it doesn't sort it in the way that I want. Candace, Christopher, Ed, Emily, Jason, John, Tom. And I wanted Christopher first. Why did I want Christopher first?
It's by length.
Oh yeah, thank you. By length. Is that what I said?
Yes.
Yeah.
Oh, by length of their characters from longest to shortest.
Wait, does that mean names.sort is already a function then?
Sort is already a function. It sorts everything alphabetically. So even the numbers. So if this was you missed this yesterday. If this is an array of numbers, it doesn't sort it 1, 2, 3, 4, 5, 6, 7.
So by
it goes
alphabetical
1, everything that starts with a 1. 1, 10,
Oh, I see.
100, and then it goes comma 2, 22, 23, 205.
Yeah,
So
that's
not
confusing.
ideal. So, but we can configure it. All we do is we tell it how to compare A and B. And we return a plus or a minus. That's what we're doing. Positive number or negative number? Negative number or 0, they stay in their spots. Positive number, they flip. So, John and Emily. Strings, John and Emily.
I'm lost.
John? Emily. And we're trying to go from longest to shortest here. Are they in the correct? If I had an array of like 2, and I said, sort this array. Longest name first, longest name to shortest name. Is this correct?
No.
What do I need to do?
Swap them.
Swap them. So it needs to go Emily, John. If you read the sort documentation or you followed along yesterday, you would have seen to swap, I need to return a positive number. That tells sort swap. If I return a negative number or 0, keep them.
How does it know where to swap it to?
Well, it's only ever comparing 2. You just tell it, all you need to tell it is how 2 things compare.
Right.
If it knows how to compare 2 things,
They'll compare all.
it can, because it's only ever comparing this one
Yeah.
to this one, this one to this one.
So it steps one at a time. It doesn't compare the whole thing.
Yeah, and in the end, it will sort the whole thing by comparing 2 at a time. So you tell it how to compare 2 is good. So if I need to swap these, that means I need a positive number. How can I generate a positive number out of these? And there's a lot of ways. I can do an if statement. If A is longer than B, if A is longer than B, swap. If B is longer than A, swap. Okay, so that could be it. And what does it mean? If B is longer than A, return +1. That works. Let's see if that works. If B dot length is greater than A dot length, return +1. Return 1. Else, return
0.
-1. Let's see how this works.
Semicolon.
Cool. This works little bit on the clunky side. Okay? Let's dig one little step deeper and see if we can come up with a cleaner solution here. Okay, this is totally fine. If you submit this for assignment, no problem. But I'm going to take you to the advanced section. Okay? Length is? What is the length of this?
5.
What is the length of this?
4.
B minus A. Return B minus A.
Right.
If B was shorter,
You'd get a negative and keep.
I'd get a negative number, 3 minus 4, and it would keep them. But it's not, it's longer. I get a positive number, swap them. So I go from this to and then if you're using arrow functions, you end up with that.
Can you roll it?
Yeah.
But in your return, your example, the Jason is before Abner. So this way, Jason is after.
Okay, so, and let me just double
Yeah, how would you
check.
do that comparison then?
Okay, so there is another,
Once they're equal,
there is another thing here. Let me just run this one and see what that returns.
it's the same. Jason after.
It has to do with what happens when they're equal, and that's where the 0 comes into play. I probably should have, which is really interesting because I ran this before and it generated this.
Yeah.
So I'm wondering why that's the case before and not now. But this happens with a 0 comparison. If I were to switch these, so
Maybe we have empty space.
oh,
You have a space, yeah.
oh,
Oh, so I thought it was another character.
no, there's
But that
Actually,
would be.
it's actually longer.
No, that was just an
It
accident.
should be before.
yeah, that was an accident.
Okay.
Yeah, sorry about that. As long as, so it should be the other way, but that's really a 0 comparison. 0, the positive, swap, negative, keep, 0, and that decides how to do it, swap or keep depending on.
I got the right.
What did you do?
Use an if and else to
I just better say equal.
Oh, okay, greater or equal. Greater or equal. Yeah, okay, you can do that too. Yeah, that works well. Okay, so then let's do that, because that will give you the real true answer. Oops.
Too far.
Yeah.
Greater or equal.
No.
no, because
Not here. I return -1 first.
You get less.
Greater,
Mm,
greater, okay, okay.
A.
A dot length,
Yeah.
yeah. A dot length, less than or equal to B dot length,
No.
Greater than
It's
equal.
the same.
and then -1.
No.
Greater than equal.
Greater than equal. Greater than equal.
You have it backwards.
Greater?
Yeah.
Greater.
Okay. So it's just that if they're equal,
Keep.
keep it. Okay, that's the bonus.
So
All right.
Emily.
That was a long one. I took extra time on this one today. Not because the exercise was so long, but because I wanted to make sure that I took the time to go through everything slowly. Okay. All right. Oh shoot! Let me just run over to the room, grab my papers off the printer. I'll be right back.
Sorry, what this +1 and -1 do again? The 1 and -1 in the example or sorting.
So the sort only accept two kinds of values,
Mm-hmm.
I like the way
greater
you
than
started
0
it.
and then less than 0.
That you're like,
So
I did it the
Sorry,
right
the-
way.
So if the sort method,
Right.
yeah. So if the returning value is greater than 0, it keeps those two values.
If it's greater than 0, it keeps both.
Yeah. And if it's less than, it's swap two
Okay.
values, which is being
Today we're
sorted.
going to
Ah,
talk
okay.
And then they will compare next
about a new topic.
So
It's going
eventually
to
you'll
go
get
for a while
sorted array.
because I'm going to exceed lunch probably. Like we'll pause for lunch and I'll come back and talk after lunch again. Today we're going to talk about something called objects. Okay, new thing. And objects are a fundamental data type in JavaScript and pretty much every reasonable programming language. Okay, you might have heard of something called object-oriented programming. I don't know, maybe. Okay. Our next course actually is called object-oriented programming, and we're going to dive much deeper into objects in that course than we are in this course. Today we're just looking at objects more or less as a storage facility, kind of like an array. Okay? With arrays, we use just values. We just store values in them. But with objects, we can store what's called key value pairs. And actually, these objects, these JavaScript objects, are used all over the place. For example, if you go into your preferences and you go to settings, there is a way to, there's something, it says edit settings in JSON. So if you were at settings and you just type in the word JSON, you'll probably come up with one of these links, edit settings in settings.json. Then you go over here and you get this, what looks like key value, key value, window zoom level 2, editor word wrap column 40, HTML format indent inner HTML true. A lot of these settings, key value, key value, key value, key value. Okay, color decorators, detect indentation, all the settings for VS Code is actually in this settings.json file, but it's presented in a nice way over here. This is a JavaScript object. And actually, JSON stands for .json, JavaScript object notation. JavaScript JS object O notation, JSON. Okay. So JavaScript objects are awesome in a different way than arrays are awesome. Arrays are awesome because we can store values in them. JavaScript objects are awesome because we can store keys and values. So for example, I'm going to make a quick user object. The syntax for object, actually let's talk about the syntax first before we start creating an object. The syntax for an object is I'm going to create an object and assign it to a variable. Okay. Curly braces. This is an empty object, just like an array is an empty array. Right? Empty braces, empty brackets, empty curly braces. Now there's another way that you might see to declare an object. This is called object literal notation. There's another one. And this is new syntax for us. It has this keyword new and a capital uppercase O. Uppercase O. Object. This is called object constructor notation. In general, right now, line 4 is the one that you want. Line 4 is the one that you're going to go with. I might ask you specifically use object constructor notation just because I want you to try it. I want you to do an exercise with it. Use object constructor notation to build a new object and do some stuff with it. Okay? So this is not an object, this is an array. Object literal notation, object constructor notation. But let's run with this. All right. So key value pairs. So that means, unlike arrays are just values. Objects are keys and values. They're like a dictionary, where a dictionary, if you were to compare an array to an array, if you were to open a dictionary and it was like an array, all it would have was definitions. It wouldn't have any word. Like, and a dictionary has the word followed by the definition. It has the key followed by the definition. But an array doesn't. It would just have definitions. You wouldn't be able to find the key. Objects are like dictionaries. They have a key and they have a value. And actually, in other languages, sometimes they're called dictionaries because they seem so much like a dictionary, because they have a key and they have a value. So I'm going to take this concept and I'm going to, so this is how we creating a new object. Creating a new object with keys, values. So I'm going to create a new object with keys, values. So oftentimes we'll find, sometimes we'll do it on one line, but oftentimes we'll find multiple lines is better, just like we can do with an array. We span it over multiple lines, and we'll end up with keys and values. So let's think about what we try to do with objects as we try sometimes to model real world things. So a user. What kind of attributes or properties might a user in real life have? Maybe a user on our website. Let's talk about what a user might be. What might they have?
Name.
They might have a name. Okay. So this is the first key we're going to assign, name. Let's give this user a name. Let's call him Bert. Check it out. We gave a key and a value. The key can be a string, or it can be this kind of like bare word. Just a word that we made up, whatever we want, followed by a colon. The value can be anything we want, just like an array. The value can be anything we want, any data type we want. It cannot be an if statement. Just in case. That coffee is yesterday's coffee for sure. Like, it was just on the warmer, and that's the only reason why it's warm. Okay. Key can be a string or a bare word. I can also write this. Give me another attribute of a user.
Last
Age.
name.
Sure. I can also write it like this. In quotes. Double quotes, backticks, single quotes. Like, I can represent it as a string.
Is this leading us to DOM?
No.
No.
No. Well, we're going to get to DOM, but this and DOM are.
I just mean like the whole object.
No.
No?
No. Okay. String, value. String or key value. Key value. We call this key value pairs because they're pairs, right? The key and the value, they're paired together. This isn't key value pair because there's two keys and two values. This is a key value pair. What I have highlighted there. Key on the left, value on the right. Again, the key can be anything you want. The value can be any sort of data type, which means just about anything. It can be a function, it can be an object, another object, it Can be an array, can be an integer, can be a string. You name it. So this is, and then we separate, just like an array, we separate the key value pair from the next key value pair, from the next key value pair with commas. Oftentimes, these keys, very frequently, here's some vocabulary for you, very frequently these are referred to as properties. So if I say, what properties does this user have? It has the name property and the age property. Okay, so we have a new user here. There's another way I can assign properties. I can either assign these key values, these properties, when I create the object, just like an array. When I create an array, I can stick them right in, right? I can do like this, const new array, 1, 2, 3, or I can add them after with an array, right? New array, at element with index 3, I'm going to say equals, well, if I followed the pattern, 4, but we'll say 10. I can do that, right? With arrays? Yeah? Okay. With objects, I can do the same thing. It looks like this. User, square braces. My new property equals some value. So key value so I can add new key, I'm adding new key value pairs. I'm adding new things to this object. But there's another way. And to really talk about this other way, we need to also consider, actually, we'll talk about the other way. The other way is user, and this is something we're familiar with using, but we haven't figured out how to create this yet. Dot. Another new property equals this clearly does not yet exist in user, so I'm adding it. This does not also exist yet in user, so I'm adding it. This is called bracket notation. This is called dot notation. So we can add properties to an object, key value pairs, when we're creating it, or anytime after, using bracket notation or dot notation. So if I were to look at this object now, I get an object with a name, an age, my new property, and another new property. That's what the object looks like now, by the time line 16 rolls around.
Very
Okay.
dynamic.
What's that?
Very dynamic the language.
Okay, so this is creating a new object, adding properties. How about getting properties? Accessing an individual property. right? Great, I added properties. You must expect that I can do more than just get the whole object back. I can access individual properties.
A question. For like, where you put in the values for user, is there a reason you have parentheses around age? The key, age? Is that supposed to be like that?
User where?
Right there. Name, and then you have age, you have parentheses, or not parentheses, sorry.
Demonstration
quotations.
purposes. That both with double quotes, you mean?
Yeah, yeah.
Double quotes works or no quotes work.
Okay. And then in BERT, you had to put it though because it's a string value, right? Or can you not put the quotations around BERT?
No, because this is a data. This
Right.
is data,
Yeah, okay.
right?
Mhm.
This is not data.
Yeah,
This is not a data type. This is like just a word that I made up.
okay.
It's not it's not even technically a string, although I can use strings for it.
Yeah.
Or I could just use like weird bare words with, and you can use like, and I can use like reserved words in here too.
Yeah. Oh, you can?
Yeah, super dumb, but and don't do that. But you can.
Okay.
I
But for-
can call this const.
So what I was trying to ask then is, the key, we don't need to put that, but obviously for the value you do if it's a string, because then
You
otherwise
need
it
to
won't
put a
work.
key.
No, but I mean, we don't need the quotations around it. That was
No,
only
you
for
don't need the
demonstration.
quotations, but the
Okay.
values you do,
Yeah.
unless it's a variable, right? Like
Mhm.
this.
Dot.
Right? This should be like almost brutally obvious by now that this is the variable has something in it,
Yeah.
therefore I can use it as something,
Yeah.
right? So yeah, you can do that, but only because this is a variable.
Yeah.
But BERT is not a variable.
Yeah.
And so it has nothing in it, has no meaning to JavaScript. This will error.
Yeah. So then we make it a string with the quotation.
Yeah.
Okay.
So would you put multiple objects like in a function so that you can call the property later?
Multiple objects.
Like let's say you have like 400 users, you just make
You would have an array of users, an array of user objects.
that's what I was
Yeah, that's good way of thinking of it. Yeah, because that's exactly what we would have. We would go to the database and we'd say, give us all the users, and the database would go, here is an array of user objects. And every user object will have a name, an age, they'll likely all have the exact same properties.
So you could call like a specific property from everything in that array. So you could be like all the names of all
Give me all the names. Give me all the ages. What's the average age of our website users? Okay, go to the database, get all the users, loop through all those users because we know how to use loops, right? Get the age out, add them all up, divide it by the total amount of users, and boom, average age of all the users of our website. Okay? Not an uncommon thing that someone would ask for. But yeah, we're only creating one right now. I'll show you how to create many shortly. Okay. So this is how we access them, and I'll come back to adding. I'll come back to adding because there's a couple special conditions that we need to consider. Accessing and adding, just like assigning variables, and assigning variables and using variables are very similar, right? If I said const a equals 5, a equals 10, a. This is setting, this is getting. The only difference is this equals. And that pretty much is the same here for objects. So user dot another property gets the value out of the property called another new property, out of user. So if I console log that, five. The value, I print out the user first, then I console log 5.
Anytime we're console logging or printing out an object, will it always print out the curly braces with it?
Yeah, but you don't use console log is really just for
For
developers.
us, yeah.
It's really just for developers. It's not for users. That's not how we print stuff out.
What if we were to alert it? Would it alert it without the curly braces?
It'd
Or-
probably
or
say
return.
object.
Oh,
Yeah. But again, you don't alert often either.
yeah.
You alert strings.
Return.
Yeah, you return most of the time. Okay, the other way, again, using bracket notation. It doesn't matter how we assigned it. Like if I assigned it with bracket notation, doesn't mean I have to take it out with bracket notation. It just means they're just different types of ways to do it. Two ways of doing the same thing, both for accessing and adding. This is 5 and 5. It's accessing the same property, just two different ways.
In the bracket notation, I can pass use a variable.
Yeah. And so, one of the big differences between dot notation and bracket notation. Before I talk about that, let me just talk about one more thing. If you access a property that doesn't exist, what do you think happens?
Undefined.
No big deal, undefined. Okay. So the question, and great question, the question is, hey wait, this is a string. And this has to be a string. You can't use not a string for bracket notation. But it's not just a string. It can be anything that evaluates to a string.
Oh, yeah.
For example, if I were to take this string and put it in a test variable, then I use the word test variable in here, because this is a string. This works too. So this is called, that is the benefit of bracket notation. One of the benefits of bracket notation over dot notation. I can't do that with dot notation. Because this is going to look for a property called test variable, and that property doesn't exist. It doesn't evaluate it.
What happens if you run the
This evaluates it. So the benefit of bracket notation over dot notation is what's called a computed, you can compute it. You can evaluate something that evaluates to a string and use it, which means it can be quite dynamic.
What happens if you run like the variables, the dot notation? Have an error?
Huh?
You have an error if you run the dot notation with the variables?
Yeah, it just won't work.
Okay.
No, it'll come up undefined.
Undefined.
Test variable does not exist in here.
Because it's not a problem.
It's not a property.
Yeah, yeah.
Undefined.
Undefined.
The other thing you can do with a bracket notation that you can't do with dot notation, and one of the reasons why sometimes you need brackets, is if you have a multi-word key with a space in it. You can't do that with a bare word. So if you wanted to have a multi-word key, when you're declaring it, you need to put double quotes, or if you're adding it like this, you need to use bracket notation. Dot notation won't work for that. So, but dot notation is the most common way of accessing these things. We do it all the time. We don't even know it. Console.log. Dot notation. Bracket notation.
That notation looks better.
So all achievers is
Dot notation. So in this case, what?
right? Dot notation. Bracket notation. This is going to look really weird. Okay? We've been using this, we've been using objects and properties a long time already. We just didn't know it. We've been using this dot notation a lot already. And it's the most common. Although, in all honesty, bracket notation is like kind of better. It's uglier. Okay? And we don't create properties with multiple words very often. So, age is usually just fine. The other thing we can do too is we can, just like we can access properties by a variable, we can also create properties with a variable name. Don't worry too much about this, I will never ask you to do this. This could be a variable which evaluates to a string, but you need the brackets around it. This is a really weird syntax. You'll see it in your reading. This is called a computed property. It allows us to create dynamic properties. Computed property. But you won't need to do that. I will never ask you to do that. I will ask you to do this sometimes.
Can we have multiple values?
No. If we want to do multiple values, we would have to give them an array. The value could be an array. Right? So maybe they have
Like one of the questions for the exercise is to rate the menu items.
so maybe my user also has skills.
Okay.
That's how we deal with multiple values pretty much generally across the board in programming. Just an array. Right? So now my user, name, age, and skills, invisibility and flight. So that's how we do multiple values. So if it had menu items or ingredients, sugar, salt, butter, oil, something else that's delicious, noodles. Okay? And again, we have this hanging comma right here.
Even the last.
The last one. Yeah, that's what I mean, the dangling comma. The dangling comma is on the last one. So that way I can just do this and add another one super quick. And I don't have to worry about getting the commas right. If there's a comma on every one, I don't have to worry about thinking, copying, pasting, is the comma there, is the comma not there? It's just always there. It's just easier that way. Okay.
All the stuff in JavaScript was an object.
Yeah, everything in JavaScript is an object, except for primitives and like structures. All data types in JavaScript are objects, except for primitives. So numbers are not, strings are not, but arrays are, functions are, everything else that we see are objects. Don't worry about that, that's for the next course, when we really dig into objects. Okay. So we have our object user. Here's something else. So can we have multiple values for a key, for a value? No, if we want to do multiple values, we create an array. We can have an object of objects. For example, user might have dependents, which could be an array of objects, right? Kids. And then your kids, maybe you have multiple kids and your kids have their names, right? Name, actually this would look like this. have their names. John, Bert has a child. Bert, who's 17, has a child named John and a child named Candace. Okay. So Bert, the object, has a key called dependence, which is an array of names. Like, this can go deep, and it's not uncommon. How do we access stuff that's that deep? How do I get the skill invisibility? Here's where everything's going to come together. How do I access that skill invisibility? If I want to pull that out. So user dot skills. But what's skills? What is skills? What is user.skills? An array. How do I access stuff in an array? Index 0. That gives me user.skills and visibility. Because this is an array. User.skills is an array, so I need to access it like an array. How do I get to user.dependence.name or user.dependence? How do I get to this name John?
Okay.
Bring me there.
User.
User
Dot.
dot dependence.
Dependence. Brackets.
User.dependence is an array.
Yeah.
Brackets.
0.
0, the first element, which is, here's something new. I'm just declaring an object in there. I'm not giving it a name. I'm not assigning it to a variable. I can do that. Just like I could just create an array out of array of arrays. Objects and arrays.
Dot.
Dot name.
Bracket 0.
No bracket 0. This is not an array.
It's not right.
Dependence, I'm in dependence. First element of dependence is this object.
Okay.
Object.name.
Oh, I'm dot. Because you have two names.
No, I know. I've got 2 objects in there, which is why it's an array.
Array determines 0. That's why you're only for
The array.
No, for the object, not the array.
Just posted that in Discord, in case you want to take a look at it and talk about it over lunch. You really gotta understand this stuff right now.
Okay.
Super critical. If you don't understand this, you gotta go back and you gotta work at this first. Right? You need to understand how to access things, how to assign things. If you can't do that, then the problem solving doesn't even matter anymore. Yeah.
For both the ages, you put them in quotes and not the number.
Oh, yeah, I just did that for demonstration, that like you can.
Okay, so it doesn't have to be like, you put this in quotes because you didn't put the number in quotes.
No, I put it in quotes because I want to show you that you can. You can put anything in quotes.
But it doesn't need to be.
No.
Okay.
No.
Yeah, I got it.
Okay, so we're gonna stop there for now. When we come back, I'm gonna talk more. We're gonna start putting functions in here. That's what we're doing after lunch. We're putting functions in objects. Okay?